James Webb uncovers a carbon-rich planet nursery. Unlike any seen before, astronomers using the James Webb Space Telescope, JWST, have identified a planet-forming disk with a chemistry unlike any seen before, one overflowing with carbon dioxide, CO2, but nearly devoid of water. The finding, made in a radiation-rich, star-forming nebula, challenges long-held ideas about the chemistry of planetary birth and may help explain isotopic puzzles preserved in comets and meteorites from our own solar system. The discovery, led by Jenny Frediani at Stockholm University and published in Astronomy and Astrophysics, shows that the building blocks of planets vary widely depending on the environment in which stars and disks form. If you like my content and want to listen more interesting science stories like this, then subscribe my channel. And don't forget to share this video with your friends, relatives, and colleagues to spread the knowledge. A disk that defies expectations. In the classic picture of planet formation, young stars gather material into a rotating protoplanetary disk. Pebbles coated in water ice drift inward from the cold outer regions. As they near the star, the ice sublimates, releasing water vapor that strongly imprints itself in the infrared spectrum. Most disks studied so far follow this rule, but this one breaks it. Instead of strong water features, JWST's MIRI instrument detected an overwhelming excess of carbon dioxide. Water is so scarce it is barely detectable, says Frediani. What we find instead is a dramatic dominance of CO2, a result that current models cannot easily explain. Radiation's fingerprints. The disk lies in NGC 6357, a vast stellar nursery about 8,000 light-years away in Scorpius, known as the Lobster Nebula. Massive, luminous stars in this region flood their surroundings with intense ultraviolet light. Astronomers suspect this radiation may be reshaping the disk's chemistry, destroying water while favoring CO2 production. Such high levels of carbon dioxide in the planet-forming zone are unexpected, says Arjan Bick of Stockholm University. It strongly suggests ultraviolet radiation is rewriting the chemistry of the disk. This means planets forming in radiation-rich regions could start out carbon-rich but water-poor, very different from Earth. Isotopes, cosmic clues. Even more striking, JWST detected rare isotopologues of CO2, molecules containing heavy versions of carbon, 13C, or oxygen, 17O, 18O. These isotopic fingerprints closely resemble anomalies found in meteorites and comets in our own solar system. The isotopic ratios we see here could finally connect today's observations of young disks with the chemical quirks frozen into solar system relics, Frediani explains. JWST's transformative view. Such chemistry was invisible before JWST. MIRI spectrographs sensitive to mid-infrared light from 528 microns can peer through dusty nebulae and reveal the unique signatures of gases with unprecedented clarity. This discovery shows how profoundly radiation fields can alter the building blocks of planets, says Maria Claudia Ramirez-Tanes, leader of the XUE collaboration, which studies extreme ultraviolet environments. Since most stars form in such regions, understanding this chemistry is essential to grasp the diversity of planetary atmospheres and their habitability. Rethinking planet formation. The implications are significant. If some disks begin life nearly dry, then rocky planets forming there may resemble Venus-like worlds with dense CO2 atmospheres, or barren, airless planets with little chance of oceans. It challenges the idea that Earth's water-rich environment is typical, suggesting instead that it reflects a quieter cosmic upbringing. At the same time, the results hint that carbon dioxide, critical for planetary climates, may be more abundant in exoplanetary systems than previously assumed. Looking ahead, the CO2-rich disk in NGC 6357 is only the first step. The XUE team plans to use JWST to study more disks in similar environments, mapping how radiation sculpts their chemistry. This is just the beginning, Frediani says. Every time JWST looks at a new disk, we learn how diverse and surprising planetary nurseries can be. Planets are not born from a single recipe. They inherit the fingerprints of their cosmic neighborhoods. With JWST, astronomers are finally reading those birth records in detail and finding they are far stranger than imagined.